Recording now. All right, welcome to your second day of Onshape. Today we're going to be looking at assemblies and kind of going over a bit what we talked about last time. So all of you worked on this sort of base plate over here. I do want to take a minute to, I guess if you could just, I'll walk around and take a look at your screens to see what you did. Again, the emphasis of that workshop was not necessarily to make the most attractive plate or even necessarily to like guarantee structural. Oh, hi, Alana. Hi. So again, the point of the base plate exercise was not necessarily to have the most attractive or the most 100% factor of safety of 3 structurally sound plate. It was more so that you get the idea of using reference geometry and using some features that you already have to create additional features, and also to sort of get a feel for where a part needs to be strong and where you can afford to take material off. So I guess I'll take a minute to sort of go around and see what all of you have done. If you haven't done anything, that's okay. You are, student person. Robotics is not the #1 priority that you should have. So I believe I asked all of you to discuss some or consider some questions. So let me just make sure I asked the right things. Okay. So I guess from the assignment that you did and from our last lecture, what kinds of relationships do you think you need to consider when you're designing a part? Yeah. Where it's going to be used. Yeah, that's really important because that tells you things like what fasteners you might need, whether or not something's going to be contacting that surface, where forces might be. That's good. Anything else? Yeah. Yeah, that's really key, especially for the holes, because if you're maybe adding a bearing to something, then you don't just want to add the dimension of the shaft, you need the dimension of the bearing. Or if you're using a bolt, you need to make sure that the bolt's not going to get sucked through the hole, Okay, those are all good. Anyone else? All right. So another one I would even mention is things like mechanical relationships, right? If you have 2 shafts and they're going to have gears connected, then the spacing between the shafts is dictated by the gears, not really whatever arbitrary value you want it to be. So let me ask another thing. How can we efficiently organize CAD files and manage sort of workload? So let's say you have an assembly and you want each person to sort of design a part in parallel with each other. How would you think about organizing that on the team? Yes. Like, do you mean the naming convention or do you mean? Yeah. I'm so glad you mentioned that. So naming systems or naming convention, do you know if the team now uses one? Yeah, we actually started one in 2016. I think it might have been lost to time. Yeah. Yeah. So yeah, having a naming convention can be really good for helping you sort out what subsystem something is for and what part or function it has. Yes, data is really good. So it would be really good to do that just so that you can organize your CAD, organize your BOM, things like that. Consider also something like a checkout system. That way, if there's a specific part where you really don't want multiple people touching it at once, you know who's using it and when and for what purpose. There are 2 other things we will be going over today, which is going to be configurations and versions. Those can also be used to organize. All right. Before we move on to assemblies, does anyone have any questions? This can be about what we just did, about what we're going to be going over, anything. All right, cool. So today, like I said, we're going to be looking at assemblies. The main thing I want to be looking at during this process is mechanical mates, looking at like how exactly you want to choose what mates you use in what scenarios. And I do also want to touch on versions and configurations. Now, no need to panic. We're not going to be assembling the entire gearbox. That is a lot of parts. And I think given the fact that you're veterans, you all know how to do mates. I don't want to like have you do the same planar and cylindrical mates over and over again. We're just going to be looking at assemblies overall here. So with that, you all have that folder where you made your plate, and we're going to be making an assembly now. All right, so your assembly layout, you'll notice it's going to look something like this. You'll have things like the mate connector, you'll have your main mates. You'll also have this sort of gear relation here, you'll have slider mates. Keep an eye on all this. And another thing of note is you do still have the measure and the mass properties, but you're also going to have these 3 new tabs, the BOM table, configuration panel, and exploded views. We're going to be looking at all of those today because, again, while I do want you to get practice with mates, I also want you to look at this workshop as a means of how we're going to organize things on the team. So with that, the first thing I want you to insert is the plate that you made. Again, completely okay if you don't have all the cutouts. As a matter of fact, I might even suppress mine since it's a lot to look at. The main thing that I really want you to have is these 4 holes for bearings and these holes for motors. Everything else, you don't need to worry about it. We just need these holes for now. Oh, also, as you notice, I'm a very bad catter and I didn't fillet any of my sharp corners. So as you can see, this would not pass any sort of stress concentration reduction test. Like this is desperately in need of filleting. But anyways, the other parts that you'll want to insert are going to be a motor. Again, we're not doing a full assembly, so just one for now. Let me check what else. You'll also need these 2 bearings over here, 2731 and 2733. All right, I guess another thing for all of you to import are the gears. So the 30 tooth, 42 tooth, the 44 and 60 tooth, and the 14 teeth, and I think that's it. Yeah, I think that's it. Oh no, there's one more, because there's 2 14 teeth. So yeah, just import those and then you can like leave them to the side or something. But yeah, just make sure you have everything loaded in. Yeah. Sure. Right. Of course. So you just hit insert and then go down to West Coast Products DS dual speed base kit, and then you just click them in. So motor, these 2 bearings. I guess for now, leave it like that. I'm just going back and forth. So yeah, just remember to sign in. Oh, one more thing I want you to do is once you have your parts imported, I want you to create a fastener mate between this gearbox and the origin. Actually, you know what? Why don't you discuss what point of the gearbox do you think would be good to constrain to the origin? Yeah, a lot of times, Onshape does take a bunch of resources. So if you have other stuff running in the background, it's good to delete them. All right, so any suggestions for where we can, like what part of the gearbox do you want to fix to the origin? Sure. So we could do this top hole right here. It's the one for the center shaft. Okay. So I am going to go ahead and fix the center of the that top hole to the, might need to rotate a little bit. I'm going to go ahead and fix it as such to the origin. So for now, I'm just going to leave it as fastened because in this case, the gearbox plate is rigid. The gearbox plate isn't supposed to be like moving, you know, it's supposed to stay in that position. And in this case, because a lot of the mates we're going to be making are going to be moving, we do want at least one thing to be static in place, not going to move. So now that you have this fixed, another thing we're going to now mate is the motor. So do you think that the motor can be fastened, or do you think we need to do anything different with the motor? Right now, everything is just sort of freely floating in space. And oh, I forgot to tell you to import the shaft. That's okay, we'll do that now. So for now, I'm going to say fastened, and I'm going to sort of hover over. Yeah, because in this case, we want something to be rigid or like something to be fixed. So we can start with this plate. Yep, and then we'll sort of mate it to the center. Oh, okay. And yeah, there you go. And again, the reason we're picking this gearbox plate is because a lot of what we're assembling is going to be assembling to the plate. So it makes sense that this is the piece we're selecting to not move, be rigid, et cetera, et cetera. It'll change your axes, but otherwise it should be fine. Yeah, so just note that if I say, like for me, is the offset might be a Y offset for you or something. So just like keep that in mind when you're orienting yourself. Yeah, pick the top center hole, because even when we designed this part, we designed using that as our relative center. So now we have this motor here, and we have a gear that's going to attach to it. So let's make the motor to the place. Because we do kind of care about the orientation of the motor, I am going to say that try to avoid using fastener mates, because again, in this case, we do care about the orientation. So we'll start with the planer mate, and we'll mate this surface of the motor to the outer surface of the gearbox as such. Hold on, it's moving on me. Okay, let's look at that. And you'll notice that it's kind of snapping to the wrong side, so you can just use the arrow to flip the orientation and then hit the check mark and you're good. However, it is also not quite in the position we want it to be in, but you will notice that when you move it around, it's still moving while being in contact or at least coplanar with that surface. So now we're actually going to mate this so that it's in the orientation we want. So to do that, we're going to start using cylindrical mates. The first one we care about is going to be this center part of the motor. We want that to be cylindrical with this surface right here. We want it to be, centered with it. So that should be nice and centered now. But the other orientation we care about are these holes for the motor right here, because these need to be bolted in, right? So we're going to do the same thing. We're going to create a cylindrical mate and mate it to the inside of this hole we created right here. And now those should be lined up. And if you hit the check mark and exit out, the motor is now fully fixed. It can't rotate, it can't translate. It is centered on that hole and the motor holes line up. What you should have right now is this gearbox plate should be fastened to the origin, and you should have a planer and two cylindrical mates so that the motor is sort of centered on these two holes of the gearbox plate. So next we're going to add this 14-tooth steel pinion gear. When you highlight over here, it should say 217, 34, 14, 14-tooth steel pinion. That's the one. And we are going to mate that to the gearbox, sorry, to the motor. But we do want this to spin, right? So if we just do a cylindrical mate and a planar mate, it's going to think it's rigid. That's not what we want. So we are going to do something called a revolute mate. And we're going to sort of go over the center. Oh, okay, so we're going to kind of go over the center as such, and we'll select this motor shaft as well, and it will snap to that position and placement. Let's say I kind of want it to go a little bit forward. I'll select offset, and again, for me, it's the Z-axis. If you selected a different face of the origin, then you might have something different. I'm going to say 0.25 inches for now. I know it's not much. Oh, let me reverse the direction of that. I know it's not much, but this is going to be important for something we go over later. And for emphasis, we're probably not going to do the entire, just do 0.25 for now. Oh, let me show you. So if it's 0, then it's just sort of going to be centered on the shaft like that. So I said negative 0.25 to push it 0.25 inches forward. Yes. You can do that too. I guess you can add an offset anyways. The reason I'm saying the offset is so that we can use this later on for something I want to show you. All right. So yeah, I'll just mess with my dimension as well. All right, so you'll notice that this gear is sort of free to spin on the shaft. Normally I'd like the shaft to sort of move with the gear since there's a pin, but this is okay for now for what we're doing. So now we need to add, was it 3-1 or 3-3 we needed to add? I think it was 3-1. No, it was 3-3. So we're going to go ahead and move this bearing 217 to 733. And we're going to make that as well. Now, in this case, I think we can afford to use a fastened because while something is turning inside the bearing itself isn't going to move. So for the sake of time, we'll say fastened. Again, sometimes this is actually no. No, actually, what do you guys think? Do you think we can have this be a fastened mate, or do you think we should do planar and cylindrical? So fastened is going to completely remove degrees of freedom, while doing planar and cylindrical would first mate, say, this plane to that plane, and then make it so that the circular surfaces are concentric. It won't be able to. So I'm glad you're asking this question because this is a case where we could potentially just do fastened. Again, for something like the motor, because the orientation actually does matter, and because we want to make sure that the holes actually line up, that is a scenario where I would say don't do fasten, but for this, we might actually be able to get away with it. All right, I will do this mate and then come to you. All right. So I guess we'll just do a fasten for now. And I am going to fasten specifically the end since we also want some level of fleshness. So I guess I'll do this surface right here at the flange to this outer surface right here. We'll flip that rotation and that's it. So you should have something like this for now. Where, oh, wrong hole. Fortunately, we can go in there and change that to the correct hole. There we go, that's the right hole. So you should have something like this. All right, so there is one more thing that I forgot to have you pull in. So I'm gonna have you pull it in right now. There are gonna be 2 shafts, I believe. That's not a shaft. We're gonna have to kind of go down. Let's check this one. Yep, this is it. So you'll also need to pull in 2733423. And we'll skip the dog gear for now. That's going to be kind of a headache to deal with. And 2173423-003. Just one of each. So 2173423-002 and 2173423-003. So we're going to do this time. We're going to do a revolute mate of this shaft because this is a case where the shaft actually is spinning. And yeah, so we're going to start by doing revolute again. And this time we're going to sort of, again, go with this sort of interface right here, since that's what's going to be sitting. And we'll do it with this bearing hole as well. Reverse direction as needed so that the shaft is sticking out like that. And hit the check mark. And now we are going to take our 42 tooth gear. And this is going to be a bit complicated because we have hexagonal pattern. But we are going to mate this to the shaft as well. Now, generally for something like this where it's hexagonal, I like to take 2 faces of the hexagon that are ideally touching or just one face apart and then mate them to corresponding faces over here. Okay, so we're going to do a planar mate. And we're going to take one surface. Remember which surface you picked. And we'll do the top surface of the shaft. And then hit the check mark. Oh, Nope, I needed a reverse direction again. It's okay, so you figure out these things as you go. So yeah, you might need to do a lot of direction reversal. It's gonna look like it's in the right place, but it's actually not. As you can see, it's still kind of turning. So what we're gonna do is kind of drag it out like that. That way you can kind of tell what orientation you're going for. For planar, I don't believe it does. I like to use the center of the plane, but if you use the edge, I think you're also okay. Because so long as you're coplanar with it, you know? So based on how I move. So to refresh on the mate you're supposed to use, I did a revolute mate for the smaller shaft, and I specifically selected the, here, I'll offset it just to show you. So I selected sort of this face right here, the end of the hole, and I selected this face as like kind of like that, if that makes sense. So I selected sort of the top part of the cylindrical part, and then I selected this sort of outer part of the bearing. All right. And okay, let me unsuppress my gear. Yeah. All right, so it is, yes. Yes, because that removes all degrees of freedom except the rotation along one axis, and that's what we want. So I'm just going to make sure I'm select my right coplanar, and yeah, so I'm going to go ahead and select this one right here. To mate it to the shaft, I'm using 2 planar mates. So I'll show you one of them again. So, all right, so there we go. So just to check. So move that in. Yep. So these planes are already coplanar. So we're going to select another planar mate, but we're going to select this plane here and this plane here. And now that it's constrained by 2 planes, it's basically constrained in all directions except its rotation, which again we want, and the actual translation of the plane. So we're going to have these 2 gears be coplanar with each other. I'm just going to hover over until I get roughly to the center of the gear. Sometimes it helps to sort of, there we go. And then I'll select this gear as well. It's going to move, that's okay, because it'll move back, and then click the X, and now they are coplanar with each other. But you'll notice that both of them are free to turn, but they don't turn with each other, right? And that's a bit of a problem, right? Because they're gears, they do move with each other. So once you get to this point, we're going to add in another mate feature. Okie dokes, that's by popular demand. We're going to be redoing the gear mates here and here. Okay, so this duder is just floating around in space, and we're going to mate it into place. So we'll select planar mate. Yeah. So we'll select this top surface of the shaft, and we'll sort of rotate and select this top surface of the gear and make those planar to each other. But we still have a degree of freedom, so we're going to select an interface of the gear, and we'll select an interface, so this outer face of the shaft, and click the check mark, and that's it. So it's literally just 2 planar mates. No, you'll have to like drag it and kind of rotate it if that helps you. Alternatively, setting the planar mate first to the other gear might be helpful too. And remember that if your gear teeth are not quite lining up, you can always sort of drag it into place for now. but there is a bit of rhyme to this reason. So another thing I wanted to highlight is you'll notice that the alignment of the gears kind of matches up with the circles we made last time, right? So if I go to part 1 and I say, I cannot show the drawing, that's unfortunate. But like if I superimpose the original sketch we made of the plate over this, you'll notice that the dimensions line up. Are you all right, Faye? Oh, okay. I only have about 10 minutes left. So I guess I'll show the journey and a few things really quickly. All right, so we have a revolute mate and another revolute mate. How do we make those revolute mates go together? We could like pair them up, but one of the easiest ways is going to be to say gear relation. And I'm going to select revolute 1 and revolute 2. And what is the ratio between a 40-tooth gear and a 14-tooth gear? What's 42 divided by 14? 3, yeah. So let's put in 3 and see what happens. And let's just make sure this, oh, what's this? Why is the outer gear spinning so much faster than the lower gear? Isn't that backwards? It's moving together. But also one of them is moving a lot faster than the other. So normally when you have a big gear and a little gear, which one is rotating faster? Yes, and can you explain why?
Okay, so what we're going to do is we're going to rotate that. See, when you click on it, it can rotate. So let's just do that. And let's go 90. And you can just type 90, hit enter, and it'll do that for you. And now it's going the same direction as that shaft. Now let's try doing a mate. So planar mate, this side, rotate, and that side. There we go, that's better now. But we still do need the other plane here to be mated. Because as you can see, here, let's go from this view. As you can see, it's constantly touching there, but not everywhere else. So we're gonna take this surface as well. Ugh. Yeah, be careful about selecting. We're gonna take this surface as well. And we're gonna kind of zoom in here. There we go. And now it can go in and out, which is fine for now, because what we care about is making sure that it's planar, because otherwise once it rotates, it's going to be kind of gnarly to get on. So, oof, lots of rotating here. Let's make this revolute to the bearing. So to do that, we're going to click on our good friend revolute mate. And we're going to click on the areas that we want to be properly distanced from each other. So in this case, I'm going to select this hole. Well, this sort of line right before the groove. And I'm going to select this side of the bearing right here. That's not the orientation we want, so we flip it. And I want you to notice how when I hit the check mark, right here, there's this little groove sticking out because that's where the snap ring is going to go. Anywho, you'll notice that they're kind of rotating together, huh? Isn't that nifty? It is nifty. It's very, very nifty. I like things that are nifty. Anyways, now that we have this bearing on and now that it's kind of spinning with the shaft, let us actually put a gear on this guy. Let's put the 60-tooth gear on this guy. So what we're going to do is we're going to do a mate as we do. And I really don't want this to be a fastened mate. So we're going to do that planar and cylindrical mate again. And the reason I don't want this to be fastened is because, again, it limits the degrees of freedom, even though we do want this to be turning. So actually, you know what? Let's try a fastened mate. Let's see what happens. So I'm going to say fastened. And I'm going to go ahead and select this inner surface again, as we do. And now I am actually going to select this outer ring right here. Cool, so that checks off. And, oh, actually, I guess it is fine. Again, Oh, I see. So I believe the reason that this works in this case is because we don't care about the gears orientation relative to the bearing, since they do move together. Otherwise, it would be a problem. So like here, you can't really fasten it properly. Like you could fasten it to here, but what we care about is that it's touching these inner surfaces here. In this case, because we have cylindrical, yeah. Anyways, now we also need to create a planar mate and make those two surfaces planar. It did move, but did it move for good? It did not. Now let's just go ahead and get this into the right position. Yeah, there we go. There we go. I like that. It's wonderful. And let's make them spin together. Now, what do we remember about the order in which we place our gear relation? Let's see what happens if we take our third revolute first and then our second revolute. And those are touching in a way that, there we go. There we go. Now that's in a good position. And remember that the relation is 60 teeth to 14 teeth. So let's say 60 divided by 14. No, stop that. They're not supposed to do that. Ah. All right. Well, for now, let's test that out. Yep, that looks about right. You'll notice that the slowest spinning one is the 60-tooth gear right here, and the 14-tooth gear is just going really fast. It's a zoomy gear. I'm going to suppress that for now, just so that I can move these into the same position. And let's look at it head on by clicking on front plane. Zoom in. That looks okay. Let's unsuppress. Really? Okay. Let's go into there and see what we can do. Okay, so I'm actually going to change that number a little bit. Really? You're not going to let me? It's just a matter of orientation, isn't it? How do I get you to behave? Well, whether or not it behaves isn't really as important, I guess, because we know that if we disable the mate, we can get it to fit properly. So I'm not too worried about that. So with that in mind, let's take a look. Yep, it's working just fine. Now let's create a second version of this with these two gears. So as you know, you have a configuration panel right here. And we actually don't care about this so much. So I'm going to go to planar 7 real quick. Planar 7, let's edit, and let's right click this and say unconfigure. We don't care. It's just going to say point on planar 7 for now. What I am curious about though is this one right here, because we did control this one in class, and this one's not quite as important given its relative size to that. So let's see what happens if we find its planar mates. Perhaps it's planar 4, not quite. Let's try planar 1. Where did the planar mate go? Well, in situations like this, there is another thing we can try. I'm going to close that configuration tab. I'm going to right click this, and we're going to say show mates. Interesting. Interesting. It seems as though the mates that are on it are that it's planar to this, but not to that. So let's check out this planar mate right here, planar 4, and edit that. And let's add a offset of about 1 inch. That's not quite what we want, is it? Let's try -1 inch. That's way too far back. Let's try 0.5. All right, is it fully 0.25? Yeah, there we go. All right, so now let's go to planar 4. And I want you to configure this distance. That way, we can see a visible shift when we switch from one configuration to the other. All right, and again, I'm not saying we should go about doing this in real life. I'm not saying that this much distance or however is okay. Again, this is mostly for educational purposes. Anyways, speaking of education, let's go back to our configuration tree. Let's switch over to the 30-tooth gear. And let us also configure the suppression of this part. So we're going to go over here and we're going to say configure suppression. And for 30-tooth gear, it is suppressed. So now we're going to go back and do the same thing with these two gears. You're going to be mating this guy to this shaft the same way. You'll be mating this to this bearing the same way. You'll make them planar and you'll give them a gear relation. So I'm going to go ahead and stop my recording for now. And when I put it back, you're going to see the end results. Pause. Okie dokie, we are back. So you should have something that I have right now. 30-tooth gear up here, 42-tooth gear over here, bearing here, nothing there. Looks good, right? Well, we still have one problem. You see, this gear 2 mate didn't really go anywhere, which means that when we spin these two gears, oh, well, for one thing, they're still moving forward. So we're going to go ahead and put a little planar mate there. Let's do that with this. No, I don't want that in that position. I want this face with that face. I want them to be planar. Okay, there we go. That's all I've asked for. So this is what we want. Yes, this is what we're supposed to have. But you'll notice still that we have this issue of gear 2. You see, this is no longer moving at the ratio we want, is it? Yeah, it's not. So what we're going to do is we're going to right click it. We're not going to say configure suppression. Instead, we're going to configure the relation ratio. And in 30-tooth, we don't want 60:14. We want 42:30. So, yep, we have that issue again. This page is having a problem. And check mark that. Nice. So remember to hit the check mark, by the way, because I hit exit on an earlier version of this and this went away. So now you have something like this. Again, the teeth look kind of off, but if you disable the mate, you can move the teeth into the proper position. Whee! So yeah. Oh, see, right there. That's the happy position. So yeah, one more thing I do want to show you is that, what was I going to show you? That was mostly it, but I'm going to go ahead and show you the versions in history. So as you can see, there's kind of a version 1 that I made earlier. There's the main one, which is now. So I'm going to go ahead and create this version v2 and say end of video. And I'm going to say create. So let's see what v1 was. V1 was just this guy. And that was done November 3. November 3. What happened November 3? Right, I imported everything. And then V2, you see all these changes here, right? And V1, the main thing you see is that it changed. So we're going to go to our main, which is everything we've created after V2. We're going to go to the workshop folder, assembly 1. Yeah. So versions are going to be really good for if there's a reason you want to go back to a previous iteration. Maybe I want to go back to a world where this assembly didn't exist. That would be a good reason to create a new version. Or maybe I modified this gearbox plate to have actual fillets instead of these sharp corners that I am specifically telling you that you don't want. But maybe I do want to go back to those sharp corners just as a demonstration to people about how to make a gearbox plate the wrong way. That would be a good reason to have a version. So that's just the tool I wanted to show you. For now, I'm going to say that's it. I want you to get to this part of having 2 different configurations. Oh, Right. So we also need to configure these gears, don't we? So we're going to do that. So we're going to say configure suppression. And for this one, we're going to say configure suppression. We're going to say configure suppression. So you should get to this point here where if I go to defaults, that gear kind of moves forward. And if I go to 32, gear moves, but also so do these two gears appear. So yeah, I want you to get to this point and I want you to try to create a new version. We will get to BOM tables, exploded views, and drawings next week. But yeah, for now, I just want you to get to this part. Thank you very much and good night.